Okay, this is the, it says Unit 7, but it's really just the polynomials and factoring our unit that we're currently in, Unit 4. These are the guided study guide notes. So notice in the first section we're writing polynomials in standard form. So we have to make sure that we have the descending degrees, and we're going to combine like terms if we have any. Let's go for it. So if I start here, a lot of times I will I will cross it off once I kind of tend to it or deal with it. Oh, my pencil is not sharp. Okay, I'm going to use a pen. This means I have to not make any mistakes. Do you have faith in me? Some of you may. Some of you may not. Okay. No. Okay. There we go. Okay, so the first term is a fourth degree term. And again, once I write it down, I'm going to cross it off. So 3a to the fourth plus, and then the next term is going to be my cubic term, 2a cubed. My next is going to be my quadratic term, or my squared term. And then I'm going to have my linear term, which is negative 7a. Last but not least, my constant is negative 4. And again, it's good to cross them off when you tend to them. Number 2, I'm going to start with my, I think it looks like I have my x to the third. X always comes before y, so don't forget it has to be in alphabetical order too. So I'm going to start with my 2x cubed, cross that off. Now I'm going to go to my descending x. So x squared y comes next. I know some of you had that question. Because you want the x's to go down in order first. That takes priority. Oh, there's my sister calling. Hold on, please. Then I'm going to tend to this one, my negative 3xy squared. Because now I have x to the third, x to the second, x to the first power. And then last but not least, I'm going to get my 8y to the third power. So again, it goes x, it's in alphabetical order, and then the highest x comes first before the highest y. Okay. The next set are classifying polynomials. You guys should be getting really good at this. Remember, if it is, you have a variable with no exponent, it's always considered linear. Just think back to those linear equations you started with, and I have a bicycle or two wheels, so I have a binomial. So the first way I would categorize this is it's linear. The second way would be a binomial. I like numbers. 24 is always 24. It's constantly 24. It doesn't really become anything else if it's just 24. And if it's one term, it's a monomial, just like a monocle or monotone. My next term, this is a pretty typical, we have a second power, it's always quadratic. And we have 3 terms, it's a tricycle, otherwise known as a trinomial. Number 6. Looks like I have 5 terms. So I'm just going to go ahead and call that a polynomial. And let's see, my highest degree is quartic or 4th degree. So remember, if you call it quartic, that's great. If you call it a 4th degree, I will accept either way. Okay. Down here, for all of these are simplifying polynomials. Write all answers in standard form. So I have to make sure that I put them in descending order as well. Okay, so I'm subtracting here. Hopefully some of you out there are saying, oh, that means I have to distribute this negative 1. Yeah, if you think about it, this is a negative 1 coefficient that I have to distribute over the parentheses. Another way to say this is when I am subtracting 2 terms, I want to copy that first polynomial, flip the sign to an addition sign, and then I'm flipping all the other signs. So I'm basically adding the opposites. Now I can look for my like terms. It looks like I have x squared, I've got a linear, and I've got some constants here. Now I can combine 2x squared minus an x squared, so I have an x squared. My next term is to combine 3 plus 4x, which is 7x. Sorry, I didn't do this very well. Let me just do 1, 2, 3. Okay. And then last but not least, I have 2 plus 1 is 3, and that's my final answer. Okay, over here I'm adding, oh man, so it looks like I have some additional work to do. So I have to distribute this out. So I'm going to wink and smile this, and then I'm going to add it to this term here. So let's wink and smile. 2 times 5, so I've got 10a to the 5th power. So I'm combining those, I'm multiplying those, I'm adding the exponents. And then I have 7 times 2 is negative 14, and I have a to the 4th power. Okay. Put that parentheses if you want, but you're going to adding that to what's above here. Okay. Now I'm going to look for like terms. So let's see, it looks like I have an a to the 5th, a to the 5th, a to the 4th, a to the 4th. And I get to combine them. So 10 minus 1, 9a to the 5th. Negative 14 plus 3 is negative 11a to the 4th power, and they are written in right form. Boom. Number 9. And by the way, I am expecting you to do all of the problems from the study guide. Okay. So here we're going to do classic. We're winking and we're doing a double smile. So let's go for it. If I multiply these out, I'm going to get 45, c to the 4th, d to the 3rd, minus 20, c to the 5th, d to the 2nd, minus 10c squared d. Hopefully you can see I'm just, again, multiplying, I'm distributing this out. This is a very standard, distribution. Okay, next is going to be number 10. Let's see what we're doing in 10. Looks like we have a double distribution bonanza. So I'm winking, smiling, winking, smiling. I got a subtraction sign here, so let's go ahead and distribute this out. On the left side, I have negative 20y squared. I have addition sign, because 2 negatives, 44y. Minus, and then I'm going to wink these out. It looks like I should have 6y squared minus 20y. Pretty straightforward. Now I can look for my like terms. Now I have negative 26y squared plus 24y. Okay. 11. Make sure I'm still recording. Yeah, I am. I hope that caught everything. Number 11. This is a FOIL. Yay, FOIL. FOIL, FOIL, FOIL. If I look at 11, I'm going to go just multiplying this out. Minus 3x minus 4x plus 3. I'm going to combine my inner terms. Hold on to my 4x squared minus 7x plus 3. Box number 12. Looks like I have these two terms. Again, I can go ahead and expand out. And then I can wink. Well, I could FOIL it, actually. Okay, I'm going to FOIL this out now. So I have 25y squared minus 5y minus 5y plus 1. These do not cancel each other out, so don't get it too ahead of yourself. This becomes negative 10y plus 1. 13. FOIL. Again, this is FOIL. So 13, I should have 2x squared minus 6xy plus 5xy. And then positive 5 times negative 5 is negative 15y squared. Okay. Combine like terms, 2x squared minus xy, because I just have 1, and it's negative winning, 15, 14. Okay, so it looks like I'm going to FOIL, and then I'm going to look for a like term. I'm hoping after I FOIL that I get an x squared, but we'll see if I do. So once I FOIL, I can go, let's see, 4x squared minus 2x plus 16x minus 8. That's that first part. And then I'm going to go ahead and subtract my negative 2x squared. They're all adding and subtracting, so I can just go ahead and look for like terms. Let's see, I have a 4 minus 2x squared is going to be 2x squared. And I have some linear terms here. Negative 2 plus 16 is 14x minus 8. 15. Okay, so here I'm looking to divide. So I could break them apart. I don't know if you guys are still wanting me to do that, but maybe I'll just do it here. So what this means is negative 8x to the 5th over 4x to the 3rd plus 28x to the 4th over 4x to the 3rd. And again, I'm just showing you how this could be expanded out. And then I could go ahead and divide them. So on the left side, I'm going to have negative 8 divided by 4, so we have negative 2, and then I've got x squared left over, plus 28 divided by 4 is 7x to the 4th over x to the 3rd is just 1x, and then this becomes, ooh, that's a 3, sorry. This is 4x to the 3rd, 4x to the 3rd, that becomes 1. So hold on to that always. Okay, I'm not going to expand these out, but remember it means this term divided by this term divided by this. So I'm just going to go ahead and go for it. 27 divided by 3 is 9. I'm going to have a c squared d to the 4th. So I get 7 minus 3. I'm using that addition sign from here. 15 divided by 3 is 5, and then I've got a cd squared. See if I'm still recording. It does like to, oh gosh, sorry about that. Can you see that? Is that better now? Hopefully that's better. Okay, I will scroll out a little bit, zoom out. Okay, the next page here. So now we're on 17. These are geometric applications, my favorites. You will see some of these on the test. We're starting to get a little better at this. So we're looking to represent the area. And if I recall, my formula is that I would multiply the two sides together to get the formula. I mean, to get the area of this rectangle. So I would like a sharper pencil. So let's go for it. I have 4x plus 1, and I'm going to multiply it by the other side. Now I'm going to distribute all of this out. So I could do this. Remember, if you're multiplying a by a trie, you have to take care of all of these terms. I'm going to have 4x to the 3rd plus x squared minus 4x squared minus x plus 12x plus 3. And you're going to notice I have a lot of stuff I can combine here. Okay, that comes first. I've got some linear terms here. Looks like I have negative 3x squared. Looks like I've got some linear terms. Sorry, these were quadratics. I have linear terms now. I have 11x, looks like, and then I have a 3 left over. Voila, done. Okay, so now I have that weird subtraction problem where I'm trying to find the area of the big and then subtract a little. So the top or the big rectangle, is x times x plus 2. Again, I'm just multiplying these two sides together. And when I multiply those out, x times x is x squared, and then x times 2 is 2x, okay? Now the little rectangle is just a 3 by 7, which equals 21. So I have 21 here, and I've got x squared plus 2x. And now I'm simply going to subtract them. So x squared plus 2x minus 21 is how I would express this. Can I combine anything, or am I kind of done? I'm actually kind of done. This is a quadratic trinomial, and I'm finished. That's as much as I can do right now. Number 19, so now I'm factoring. So this is a bonanza of factoring. And make sure, remember our golden nugget here, I don't know what I'm talking, yeah, I guess I can call it golden nugget, is I'm looking for a greatest common factor first. So if I look through this, I already recognize a 9, because I know these are all multiples of 9. I also see that they all have an x and they all have a y. I'm going to extract my 9xy. I'm going to divide it out. I'm going to end up with 6x squared. I'm going to divide these terms, negative 2xy. Divide these terms, looks like I'm going to have 3y left over. And that's the answer. So extract, put it outside the parentheses. Number 20. My spidey sense goes off with number 20 because this is a DOS. DOS means difference of squares. I got two square numbers. Write the square root right underneath, which is 3x. And then I have the square root of 49, which is 7, and then y squared. I'm going to do my plus minus, and now I'm going to rewrite it, because those are my factors. 3x plus 7y, 3x minus 7y. Okay. Now, 21. Is this a difference of squares? Well, maybe, but let's do the greatest common factor first. Well, you know what's funny is that 16 actually goes into 64. So let's try that. What if I factor out 16 and then y to the 4th power? Okay, I can do that. 16y to the 4th power goes outside, and let's start dividing it. Well, it's just 64 divided by 16, which becomes 4 minus 1, and then you have 1y left over. No, you have 2 y's, so you have y squared. Now this is kind of interesting because these are actually a difference of squares. We've got a DOS, we've got a GCF, and a DOS, which is a difference of squares. So what that means is hold on to what you factored out and think about what the square roots of these are. So I've got 2 as the square root of 4, and I've got y as the square root of y squared, and this becomes 2 plus y times 2 minus y. Number 22. Okay, we have a standard trinomial here. We don't have any coefficient, but I think that I can actually get a greatest common factor here. Every term here has an n. Oh, that's kind of cool. So maybe I can get n out of here. Let's get how it extract our n's. What do I have left here? I have n squared minus 5n minus 50. And now I can play so this was a GCF, and now I'm going to play I think that I called this Possum. Who was I talking to? The Possum method. Was it Tanner or Eddie or, wait, who was it? Charlie? I can't remember. We're calling it the Possum Strategy, where I'm looking for the sum and the product sum game. We shortened it to Possum. If I have 50, I'm looking to get to 50, that's a negative, and then a negative 5 with my factors. I'm going to go through all my factors, and I think what I'm going to do is probably a 10 and 50. A 10 and a 5. So what about 5 times 10? Is that going to work? And the negative side wins? Because that would yield me negative 5. Okay, so I think this is the winner. So I'm going to rewrite this, first of all. Hold on to what I factored out, which if you remember earlier, I factored out an n. So you still have to hold on to n, and then I'm factoring this trinomial into n plus 5, n minus 10. Okay. Number 23. Oh dear, I think this is probably a grouping. This is like sibling rivalry. So let's go, or should I factor? Yeah, let's do sibling rivalry. Let's break it up into 2 parts. And then let's try to find the greatest common factor. So I'm going to find, I think this one's going to be 4x squared over here. This one is going to be negative, because remember when you have a negative coefficient, the factor has to be negative. Negative 25 goes into both. 4x squared, take that outside. Oh, I need a lot of room here, I think. I'm sensing that. 4x squared, outside, divide. X plus 3 minus 25. And then what's left here is x plus 3. Oh, yay! So I have 2 factors now. Remember, that was my goal. If I have sibling rivalry, I'm looking for that common thing that they have. A common factor, which is the love for their mother, which is really represented by x plus 3. So that becomes the what? That becomes one of my new factors. Whatever is left becomes my other binomial factor. You know what makes this interesting? Some of you might be sensing. This is a difference of squares. Isn't that cool? I could actually rewrite this again. I wish I had more room. I am going to write this over here. If I 4x squared minus 25, well, guess what that means? That also means 2x, this is a difference of squares, plus 5 times 2x minus 5 times, and I'm sorry this is so messy, x plus 3. All of these 3, I'm going to put that in a box, are multiplied together. These are actually the factors of this. That's actually kind of cool. I like that. Okay. Over here, I could probably factor something out if I look quickly. I think 3 goes into all of these. If I factor out a 3, pull out my 3, I'm going to end up with k squared minus 19k plus 60. Now I can do the possum game. I can get to 60 and negative 19. 60, I can make my table, negative 19. I need 2 factors. Oh, 1 and 60 are not going to work. 2 and 30 are not going to work. 3 and 20, no. 4 and 15, no. Oh, and they both have to be negative. So, because when I add those together, it will be negative 19. Okay. 3k minus 15, k minus 4. Both negative. Am I still recording? Yes, I am. Okay. 25. So it looks like I'm going to have, I bet this is going to be maybe a slide and divide. So 25, I'll have, yeah, because I can't factor anything out. So I'm going to slide the 4 over. I'm going to rewrite this as 4 times 14, which is 56, and it's going to be negative. Now I'm going to do this possum game. 56 is negative 56 is my goal, as is negative 1 from my negative 1m. That's an invisible coefficient. Alright, they have to be 1 apart, so I think I already know it's going to be an 8 and a 7. And the dark side wins, so the larger number is going to be negative. Yep, because that's going to be negative 1. Okay, terrific. So then this is going to be m minus 8, m plus 7. Am I done? I'm not, because I have to now go back. This is slide and divide. I have to go back to undo my 4 that I multiplied by the constant. So now I have to divide it over here to both constants. I have to simplify each fraction. Well, 4 into 8 is 2 times. So really this, I can rewrite this m minus 2 because I can simplify this. Can I simplify this though? I can't. If I can't simplify it, then slide this 4 back in front of that coefficient, and then you're done. 26. Let's see, it looks like I can, they're all even, which is nice, because I can extract a 2. 2. And then what's left over? I got 4r squared plus 8r minus 5. I have a feeling I'm going to do the slide and divide. Slide, divide. Like a triple whammy here. So I'm going to split this in half here because I'm going to need more work space. I'm looking for factors of, oh no, I'm going to slide this over. Yeah, that makes sense. Okay, so 2, I'm going to rewrite this r squared plus 8r, and then I'm going to end up with 20. Okay. Now I get to do the slide and divide and the possum. So this is possum, meaning product sum game. I need factors to get to 20 that get me 8. I could do my work over here. Negative 20. I'm looking for a difference of 8. 1 and 20, 2 and 10. Oh, 2 and 10. Is that going to work? Like, here's my little table here. Sorry. I think that 2 and 10 will get me 8. Okay, so let's do that. So I can rewrite this. 2 r squared, sorry, oh my gosh, plus 10, sorry, I'm taking this from over here, and then r minus 2, because 10 minus 2 is 8. Okay, I am not done, because remember, I have to now divide it by my original 4. I'm going to rewrite it up here again. 2r plus 10 over 4, r minus 2 over 4. Can I simplify 10 over 4? I can. This becomes r plus 5 over 2. And this becomes, oh, this is a half. R minus a half. Now I can rewrite this. Oh my goodness. I can't simplify 5 over 2 anymore. So this becomes 2r plus 5. And then I have to move that 2 over here. 2r minus 1. Wow, that was a lot of work. Okay. Now, this is kind of cool. A rectangle can be represented. That means that the area, if you think about it, here, I can even draw a picture of this because I like pictures. A rectangle, the area of this rectangle, for example, is this. Length times width of this rectangle equals this quadratic trinomial. So I'm looking to have 2 binomials to yield me this. Well, isn't that just factoring? Yes, it is. So I'm going to factor this out. So really, I could play the product sum game. I need a negative 14 and I need a negative 5. So I'm going to factor. I think I've got a 7 and 2 that's going to be good for me. It's got to be, one of them has to be negative, and then the dark side has to win. So it's negative 7 plus 2 is negative 5. That's going to win. So I would rewrite that. X minus 7, x plus 2. If I were to then check my work, which I could, basically this could be the length, this could be the width of my rectangle that yields me this as an answer for the area. Cool. Okay, we're almost done. 28. Divide. So I have to factor out number 28. So I'm going to do the product sum game here, and I'm just going to show you. If I factor this top polynomial out, I'm going to have x minus 6, x minus 8. Because negative 6 plus negative 8 is negative 14. Negative 6 times negative 8 is 48. This is the factored poly. Now I'm going to rewrite this because I'm going to stick it over my denominator, or what I'm dividing it by, my divisor. And guess what? These cancel each other out, and what I'm left with is x minus 8. Please tell me I'm still recording. Oh, I am. Then I have 29. I have p squared minus 9. Oh, that's kind of fun because I can fact, it looks like that's a difference of squares. So I have p3, okay, p plus 3, p minus 3 over p minus 3, and these cancel, so I'm left with p plus 3. Last but not least, number 30. Oh, wow, this is a good one. 30, so I'm going to factor out, oh my gosh, my sister is calling me again. I am going to factor out some stuff on the top. So let's forget about the b plus c for a minute. Let's just deal with the top. In fact, I could actually regroup this. I need a sharper pencil again. I'm writing so much. I'm going to regroup this. Sibling rivalry, and then I'm going to extract. If I just look at the top left side, I'm going to get my A2 out of here. And I'm going to divide this out. So I am basically factoring out, finding the greatest common factor of both of these terms. And now they match. Okay, so I have this that matches. So I'm going to rewrite this on the top as a squared minus 5 and b plus c. This means the same thing as this. This means the same thing as the numerator. I have not done anything with the denominator yet. Make sure you understand that. These are different lines. But now this is the factored form of this. I am now going to stick it all over my original denominator, which is b plus c. And guess what I get to do? I get to cancel those out. They become 1. The final answer is a squared minus 5. Okay. You're going to do great.